how about if I said 2 plus 2 plus 2? What would that be? 6. Okay, all right, we're doing pretty good. What if I said 2 plus 2 plus 2 plus 2 plus 2? Yeah. What would that equal?
10.
10. We got 8 and 10. We agreed on one of those two?
10.
All right.
Yeah.
I want to ask, somebody tell me how they got 10 in that last answer.
1, 2, 3, 4, 5 of them. 5 times 2 is 10.
That's our shortcut. We've learned multiplication, and we can say, instead of writing out all these 2's, we can write 2 times 5. And we know, because we learned our multiplication tables, that's 10. We can do the same thing with, if I added up 5 3's, we could say 5 times 3. Well, multiplication is kind of a short way of writing long addition problems. We have the same sort of thing for multiplication. And that's what we're learning today. It's called exponents. And exponents, well, we'll start like this. What if I did this? I said 2 times 2. What would that equal?
4.
What if I said 2 times 2 times 2? 8. Well, we don't learn exponent tables, but there's still an easier way of writing long multiplication problems. Just like this, 2 times 2 times 2. There's a shortcut. We can do what's called using exponents. We can write that as 2 to the third. And that third is an exponent. And all it means is we have 3 2's in our multiplication problem here. So, what if I were to write something like 2 to the 5th? How would I write that out long ways, like we wrote this? Like 2 to the 3rd. What do you think that means?
5 2's.
5 2.
And that equals, can you tell me that equals?
3.
10. 2 times 2 times 2. What's 2 times 2?
4.
What's 4 times 2?
32.
What's 8 times 2?
16.
And 16 times 2?
32.
All right.
32.
So 2 to the 5th equals 32. And just like in multiplication, there's little easy things in exponents. Like in multiplication, you have 2 times 0 equals 0, 5 times 0 equals 0. You know that anything times 0 equals 0? Well, with exponent, or same example with 1, anything times 1 equals itself. 5 times 1 equals 5. 10 times 1 equals 10. In exponents, we have certain things like that. For example, anything to the 0 power equals 1. So 10 to the 0 equals 1. If I said 5 to the 0, that equals 1. Anything to the 0 power equals 1. So what if I said 7 to the 0? What if I said 6,498 to the 0?
6,000.
Is it 6,498 or is it 1?
1. What's
One?
0 to the 0?
Oh my God. I think it's 1, but it's 0. Right, it's 1 times 0.
But you just said any number to the 0 power is 1.
Okay, well, we can deal with smart asses questions. How we write is like this. I believe 10 to the 0 is actually 1. When you write like 10 to the 2nd power, 10 squared, you're actually writing like 1 times 10 times 10. And we just a lot of times leave out that 1. And so if I write 10 to the 1, I just have 1 times 10. But if I write 0 to to the 6th power, it's going to be 0 times 0 times 0. If I write 0 to the 1 power, it's going to be 0 times 1, 0 times 1, and that equals 0. Okay. And the other thing is anything to the 1st power. For example, 10 to the 1st power is going to equal 10. It always equals itself. It's kind of like in multiplication, 10 times 1 equals 10, and so forth. 6 to the 1 is going to equal 6. And what would be like 7 to the 1?
7.
How about 47 to 1?
42.
Okay, the other thing.
Cheryl had a question.
Gerald, do you have a question?
Can you have negative exponents?
No.
Not today.
We're going to go over that one tomorrow. Yes, we can. Very good question. We'll go over that one tomorrow. I want to look at this 10 thing because this is also an interesting thing. If I have 10 squared, can someone tell me what that would be?
100.
That would equal 100? What if I had 10 cubed? How do we get 1,000? How do we get 1,000?
10 times 10 times 10.
That's 3 zeros.
Somebody just pointed something out already. And that's it. This has 3 zeros. This has 2 zeros, and this one has 1 zero. There's a pattern here. However, if you have 10 to something power, you have that many zeros in your answer.
So does that mean 6 to the 3rd is 6,000?
Only when it's 10. Only when your bottom number is 10. We won't go into it, but this is called the base. But this is just consider this your bottom number. Whenever this number here is a 10, then you have 1 to this many zeros. 1 to 1 zero, with 1 zero, 1 with 2 zeros, 1 with 3 zeros, and so on. So if I had 10 to the 4th, I would have 1 with how many zeros?
1 to 4.
4. If I had 10 to the, say, 57th power, how many zeros would I have?
57.
And our book decided to find out how many $1 bills it takes to make 1 pound. And so they piled up on a scale somewhere several $1 bills, and it turns out there's 454 it takes to make 1 pound. So if you take 454 bills, put them on a scale like this, your money over here and your pounds over here, you have 454 bills. It's going to weigh 1 pound. And now my question is, how much does 1 bill weigh? And I want to ask if anybody out there can guess. Knowing that 454 bills weigh 1 pound, how would you be able to decide how much just one $1 bill weighs? Gerald.
Well, since one's gonna be so small, would you want us to convert it to ounces first?
Let's not do that right now.
No?
Let's think of another way we could do it. Knowing that we have, go ahead.
Then wouldn't it be 1 over 454? Like a
Okay.
fraction?
Okay, why do you do that?
Because you want, if you know that it takes 454 of these things to equal 1 pound, and you want one of them, or if you just want the weight of one, then you divide.
Very good, because if I divide by 454 on both sides, just like we would on any algebra problem, you do something to one side, you do to the other. If I divide this side by 454, I get 1. And if I divide the other side by 454, I get 1 over 454. Or, we'll pretend you guys have calculators. and your calculator answers came to 0.0022026. But some of you also got another number. Some of you got 2.2026 times 10 to the negative 3. I got both of these answers from you guys for 1 over 454. Are these answers the same? Anybody tell me? You might not. I mean, some people might. Theoretically, some of you would. So, someone can say something if they want to. Okay, nobody knows.
They are the same.
They're the same.
They are.
Okay, they are the same, yes. What happens is some of you have calculators that have scientific notation on it, and if it does, you'll get an answer that looks like this. And basically, all you have to do to convert this into a regular-looking number, one that we're used to working with, is you see you got 3 here. The 3 means you're going to move the decimal point 3 places to the right or to the left. And in math, like if you think of an x-axis or something, which side are the negative numbers on? Are they on the left or the right? They're on the left. So if we have a negative 3 here, we'll move 3 places to the left. And we'll fill in those empty things where there's no numbers with zeros. And our number looks just like this one, 0.0022026. So I'm going to go ahead and put this number up here. And that is how much one single $1 bill weighs. 0.0022026. But I have another question. My other question is, I have $1 billion. I just won 5 lotteries in a row. I've got $1 billion. And I want to know how much I got paid in dollar bills. And I want to know how many pounds of dollar bills I have if I have $1 billion. First, let me write 1 billion. Does anybody know how many zeros are in 1 billion? Let me leave this up.
9.
Okay, who says 9? What if I said 12? What would 12 zeros be? What number would that be?
Trillion.
Okay, a trillion. So 9 zeros would be like a billion. So, we've got a really short board here. We'll write, I got $1 billion inside. 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to know how many pounds I have to put on this side. How many pounds does $1 billion make? Can anybody tell me how they would figure that out? Multiply what?
Well, if one of them weighs that much, then you have to multiply a billion times that.
Okay.
Times the,
They have to keep the scale balanced.
Okay. Does anybody know any other ways I can do it too? Back there, Daryl.
You could, since there's 9 zeros on this side, then you can move that 9 decimal places to the right.
Very good. You actually jumped ahead. Very good. That is true.
no,
There's a couple ways we can do it. We can multiply the way Mary and Gerald said. Multiply this. You can also look at this and say, we know that 454 bills weigh 1 pound. So if we have a set of 454, all we need to know is how many sets of 454 are in a billion, and that'd be the number of pounds. If there are 30 sets of 454 $1 bills here, then how many pounds do I have here? 30. Okay, so I can do it either way, and it's going to work. We're going to do it by multiplying. So if I multiply 1 billion times 0.0022026, and I don't want to do that with a calculator because that's a lot of keys and stuff to put, I might do it Gerald's way. And Gerald's way was, we know there's 9 zeros here, so all we got to do, if we're going to multiply something with 9 zeros, is move the decimal place over 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives us 2 extra zeros at the end. So our new number becomes 2202600. So that's a lot of pounds. Does anybody know how many That's actually it's 2,202,600 pounds. Usually when we see that many pounds, we write it something different. We write it in tons. Does anybody know how many pounds there are in a ton?
2,000.
Hey, all right. So, let me get rid of this right now.
Or you could write 2.2 million.
Right. 2.2. Okay, so there's 2,000 pounds in a ton. How would I be able to find out how many tons are here? I know that a set of 2,000 pounds equals 1 ton. How could I find out how many tons 2,202,000 is?
Multiply
Multiply what?
2,000 times
Times this one?
right.
Okay. Anybody else? Gerald?
Don't you divide?
Okay. If we want to know how many sets of 2,000 are in this, and if we divide 2,000 into 2 million, we'll get how many sets of 2,000 are in 2 million. And if we were to multiply, we'd get an even bigger number. We wouldn't get a smaller number, and we know we want a smaller number, as there'd be no point in converting this to something even bigger. So it turns out if we divide 2,000 into 2 million, we get something close to 1,101. Yeah. We get something close to 1,101 tons. That's quite a bit of money. 1,101 tons of $1 bills. And if, say, I wanted to bring that money somewhere else and I wanted to use a 2-ton Ford 4x4 pickup, how many pickups do you think I need? If I knew one pickup, one pickup carries 2 tons. How many pickups do you think I'd need to carry all that money? About 550, 551, depending on if you want to do that last ton. Maybe you take that last ton and buy your trucks with that. So, you need 550 trucks just to carry one.
No, in the video. We don't want any. I throw my water at you. Look, I dare you. No, I mean, open it. You just throw water on it? Anyway, throw that one. I'll try you throw it. I'll change it right back into it. And if it's water, I'll just like, you know, once I change it. I'll get it in my mouth like that.
Get out of the pencil and say, give you the half right there. We're gonna write it down.
5:30 yesterday.
Before we do anything, I need everybody to go far away.
Before we go over to the card game, we're going to predict on our papers how long we all think it's going to take, and what things might cause it to take longer or shorter. For example, there might be wind over there. Maybe the person will push it instead of letting it drop. That happens a second. Instead of letting the pendulum drop, kind of push it. That would be one. Write it down. Write down some different things that might affect what happens when we go out there. You'll want to see if it actually does happen.
Me and Tim get out at the same time, it's right next door to me.
I mean, Mondays.
What?
Everybody in the group will have one of these, you have this down, it's gonna come in the end of class.
Hey, just so they know I'm making it to fail. They can like make it.
Right now, and just be doing this warm up.
And then bam. Yeah, they want to coordinate. Greenhouse.
Well, let's see, I gotta get off the end of the day.
What you take? Right here.
Oh.
Film that I asked them not to talk.
Oh, sorry.
You know what I'm doing for lunch?
Oh, yeah.
I'm not gonna find homework.
When?
How long did you say it
Hey, I didn't spell weather right.
Whether what?
Justin, Brad, Joseph, I don't have your. Okay, Brad.
You call my mom.
You don't have it at all?
No.
Okay.
I never got one of those little slips. Why don't you just sign it?
I mean, your mom, he's just friends
We'll
with
work on
mine.
something.
Across the street.
Chris, can I have your attention too? When we go over there, there's going to be two different jobs that I'm looking for people to fill. One is only going to require one person, and people are already guessing which that is. That's the person who's going to drop pendulum. I'll pick that one.
I want to be the fireman.
The other positions will be for people who will be the timers.
I want to be the victim.
For the swing, I will, since there's more than one hand and there's no diplomatic way to do it, I will go to the seating chart and just
I love it. Hand on the first.
Yeah.
I don't want to. I want to be a fireman.
Okay, I'm going to randomly put the pencil down on some name.
That's not even our class.
Here. Go to work.
But what if it's not the person wants to do it?
Then we'll do it again.
So like, there's not-
Oh, yeah.
Farah. Where's Farah? No? Okay, one more. Steve. Would you like to do it? And he'll have good aim.
What is that?
Kill the golfer.
Now, who would like to be the timers with the calculator?
Oh, wait, I'll be Mr. Miller! Mr. Miller! I'll take my wallet.
Hey, come on, just-
Oh, never mind. I know, I thought you had that. Okay, leave it there.
Mr. Harvey. I mean, Harvey.
You have it on me. I'm coming.
Yeah.
Why is this religion trying to be apocalyptic? Hi, Jennifer.
Wow. He wants you to hit the wall.
Oh wow, so high.
3.
Hey, are you from the, is he from the newspaper? Is he from like the newspaper or something? Let's get our picture.
Is this taking longer or slower than you guys do that?
Hey, maybe. Hey, newspaper guy, whoever you are.
Is he from the newspaper?
I don't know. Tell him to get out of the way, all right? With a big camera like that.
No, let him say that because I'm gonna get my picture taken right now.
Yeah.
I don't think so. Just grab the camera.
I'll hang on to the pendulum.
Hey, isn't it from the club?
Yep. 9.
9.
How much? Oh, we don't know the time yet, do we? 10.
Hey, it's more than 72.
Does this take you longer than the minute?
75. 76.
11.
I think it's gonna be more. I think it's gonna be like
Get ready to stop.
12. Stop, Terry!
12, stop.
76.2.
What did you guys get?
806.2.
Let's go.
Let me go ride.
Why don't somebody jump on?
4.
Hey, kneel down. Ah!
6. 7.
Hey, we gotta do it 5 times. 9. Stop pushing me, help it out. Just near that board up there, just moving. Moving along. The last one. What are we on? Ready? 12. Stop. Stop.
What did they get for the time last time?
She pushed it. She didn't let it go. She pushed it. That doesn't stop. That's a falsely start. She pushed it instead of just doing it. Hold it higher, Deanna. Deanna, put it higher. Get on your tiptoes.
Okay, this is the highest one. Hey, Deanna. Let's see what
Ready?
happens.
Tiptoes.
Should it make a difference if it goes higher?
No. Yeah, but I think so. Yeah. It does. It didn't say go. It does make a difference. To hit you, Matt.
If it hits that little metal thing, it'll matter.
That's right there. Ah! Hey, one of my predictions were right.
Will that affect our swing?
Yeah. And it hit the wall too.
We'll let it go. We'll let it go. No, hit it.
That hit it. I don't care. You said that was gonna happen. What swing is it on? Hey, is anybody counting? Nobody's counting. We have to do it again on counting. No one counted. Nobody counted the swing.
Oh.
We gotta do it all over again.
Why?
On stage. 11. 12.
All right, let's get them up front. Let's get one picture of the class.
Oh, wait. He said I take
You guys are short.
Now have it out in front. Have it out in front. Don't hold it up. Okay, you need to move in. Who you right here?
More?
I want to get everybody in. I don't want to get back here.
Ow.
Okay, Jennifer, you're standing right in front of the pendulum.
Yeah.
No, you don't have to do that. You can just stand so that you can see the pendulum. All right. I'm going to take another one. This time, everybody smile. No. Where's this? Oh, there you are. No. Kind of, yeah, we need your whole head in there. Hey. Okay, here we go. Thank you very much.
All right, back to the crosswalk.